This is question number 1 in the non-calculator. We're asked to evaluate, and we have two fractions and a mixed number, an addition and a division. So the rules of BODMAS tell us that we'll have to do the division before the addition. So we have 2/3 divided by 1/5. This 1/5 will need to be changed to a top-heavy fraction before we can attempt to do that. So we'll start off by writing down the next line of working. So that's a half plus 2/3, and then divided by 1 1/5 will be 6/5 as a top-heavy fraction. The 1 times the 5 gives you 5, add the number 1 in the top gives you 6, and that's all over 5. So we have a division to do first, but we must remember that we never actually divide with fractions. Instead of doing a division, we're going to do a multiplication, and the rule is that we flip the second fraction upside down. So multiplying by 5 over 6 here will give us the same answer as dividing by 6/5. So we still have our half and our plus. We'll do that at the end. We'll do our multiplication first. So top times top, 2 times 5 gives us 10. And bottom times bottom, 3 times 6 gives us 18. So we now have a half plus 10/18. Now in order to add two fractions together, we have to make sure that we have a common denominator. So we can get that in this situation if we multiply the first one by 9 on the bottom. Remember, if we multiply by 9 on the denominator, we must multiply the numerator by the same amount. So that will be 9 over 18 plus 10 over 18. Adding those two together then gives us 19 over 18. Now this itself is a top-heavy fraction, which means our answer is bigger than 1. So in order to find out what the answer is as a mixed number, we have to see how many times the 18 will go into the 19, which is obviously once, with 1 left over. The 1 left over goes on the top, and the denominator stays the same. So the answer is 1 and 1/18. This is question number 2 in the non-calculator. We're asked to expand and collect the like terms, and we have double brackets here, so we want everything from the first bracket to multiply everything by the second bracket. We'll do that one thing at a time. So first of all, the 5t from the first bracket has to multiply the second bracket, and then the -3 from the first bracket also has to multiply the second bracket. So we have 5t times 2t, the 5 times 2 is 10, t times t is t squared, take away, and then 5t times 4 is 20t. Then we have our -3 times 2t, which is -6t. And then we have -3 times -4, so the answer to that will be positive, and 3 times 4 is 12. So we're looking for like terms. In the middle here we have -20t, and then we have another like term, -6t. So we're going to combine those. The 10t squared goes on at the front. -20t take away 6t is -26t, and then our number at the end is plus 12. There are no more like terms, so that is our final answer. This is question number 3 in the non-calculator. The cost of a holiday increased by 8% from the years 2001 to 2002. If it cost £540 for the holiday in 2002, what was the cost in 2001? Now this is another example of reversing the percentage change question. Our holiday price has increased by 8% from its original value. So its original value, if it's represented by 100%, then this new value is represented by 108%. So that's what we'll start with. 108% is equal to our current cost, £540. Now, from attempting these questions previously, you should remember that the aim of the question is to get back to 100%. That would represent the original value of the holiday and give us our answer. Now we need to find a way of getting from 108 back to 100. We don't do that in one step. We have to find an intermediate percentage, one that we can easily divide from 108 and then multiply to get back to 100. So without a calculator, this might seem like a difficult task for this question, but when we notice that 54 is half of 108, then that should give us an opportunity to look for a percentage we can work with. So that percentage is going to be 2%. So we're going to get 2% by dividing our original percentage by 54. Now division by 54 would normally be something that's quite difficult, but since our number is 540, divided by 54 is actually very easy. The answer is just £10. Now that we have 2% equal to £10, again it's straightforward now to multiply by 50 to get back to 100%. If we multiply by 50 on one side, then again we have to multiply by 50 on the other side, and 10 times 50 is simply £500. That's our answer, the original value of the holiday. This is question number 4 in the non-calculator paper. The cone has diameter 20 centimetres and height 30 centimetres. We're asked to calculate its volume. We're told to use pi equals 3.14 and give our answer to two significant figures. Now at first glance we might imagine that this would be in a calculator paper, but then we are told to use pi equals 3.14, and hopefully this also means that some of the calculations will work out to be fairly straightforward. So the first thing we want to do is write down the formula for the volume of a cone, which is V equals 1/3 pi r squared h. So we know that the diameter of the cone is 20 centimetres, which means the radius is 10 centimetres. So that's good, that's nice and easy to work with. And up here we're told that the height is 30 centimetres. So if we take those and substitute them into our formula along with 3.14, then we will get V equals 1/3 multiplied by 3.14 multiplied by our radius squared, so that's 10 squared, multiplied by 30, the height. So at the start here we have 1/3, and over here at the end we have 30. So we have a number of terms to multiply, but there's no reason why we can't multiply the third and the 30 to begin with. That's convenient here since we don't have a calculator. 1/3 of 30 is simply 10. So in the next line of working, those two will give us 10. And we're left multiplying that by 3.14 and multiplied by 10 squared, which is 100. So what we're expected to do now is multiply 3.14 by 10 and then multiply it by 100. So as we hoped, the calculation has worked out nice and easy, multiplying by 10 and 100. So first of all, we have our 3.14. We'll write that down first. So to multiply by 10, that means we'll move the decimal point one place to the right, and then we want to multiply by 100, which means the decimal point will move a further 2 places to the right. So first of all, we'll take a jump over the 4, and then we'll need to add a 0 so that we can do our final jump. So decimal point ends up on the end. So what that means for our volume is it's actually 3,140. Now often that would be the end of the question, but it's always important to reread your question at the end to make sure you have answered everything. So we look back, we will remember that the question asked us to give our answer correct to two significant figures. So looking at our answer again, the two significant figures are these two, 3 and 1. So that means our volume is 3 and then 1. It stays as 1 because the next numbers are 4. And then the 4 and the 0 are replaced by zeros as placeholders for our number. That gives our answer correct to two significant figures, 3,100, and that is cubic centimetres, the volume of our cone. This is question number 5 and the first one in the calculator section. Amanda is a secondary school teacher. She earns £32,500 per annum, which means per year. Her union agree a 3-year pay deal which will see her get an annual rise of 2.6%. So again, annual means yearly. How much will Amanda earn in 3 years' time? Give your answer correct to the nearest £100. So we're talking about an increase, 2.6% added on to the original percentage, which would be represented by 100, is 102.6. If we were then to write that as a decimal, that then becomes 1.026, and that's our multiplier. So we start off with 32,500. The multiplier, as we mentioned a moment ago, is 1.026, and it's over a 3-year period, so that tells us that our power is 3. We then take that and put it into a calculator to work out our answer. That gives us 35,101.4812. So we know this answer is in pounds. We're asked to give our answer correct to the nearest £100. So that would be 35,100. That's our answer and the end of the question. Question number 6 in the calculator paper. A pharmaceutical pill is shown below in the shape of a cylinder with hemispherical ends. The radius of each hemisphere is 0.6 centimetres and the cylindrical height is 2.4 centimetres. Calculate the volume of the pill. Give your answer correct to 3 significant figures. So our hemisphere up here at the top, along with the hemisphere down at the bottom, together they will make a full sphere, and in the centre between the two is our cylinder shape. So we've clearly got two separate volumes to work out. The volume of a sphere, which is the two ends put together, and the volume of the cylinder. We'll work out the sphere first of all. So we'll take a little heading, make sure that our working is nice and clear. And the volume of a sphere is 4/3 pi r cubed. So we can see that our radius of the sphere is 0.6 centimetres. So that means V equals 4/3 pi multiplied by 0.6 cubed. Now doing that on our calculator gives us our volume. Now we want our final answer to be correct to 3 significant figures. So we'll take our working here to 4 significant figures. So that's 0.9048 cubic centimetres. Now that's the volume of the full sphere, the two ends put together. What we need now is our cylinder. So once again, we will take a separate heading for that. So our formula for volume of a cylinder, V equals pi r squared h. This time we'll need to know the radius and the height of the cylinder. So quickly have a look back at those. The radius of the cylinder is the same as the radius of the sphere, 0.6 centimetres, and the height of the cylinder is 2.4 centimetres. So substituting those into our formula, V equals pi multiplied by 0.6 squared multiplied by 2.4. Once again, we can do that on our calculator and correct to 4 significant figures, which gives us 2.714 cubic centimetres. So we now have worked out the separate parts. The next thing we want to do is we want to find out the total volume. So I'll give us a little bit of space here to do that. So that will give us our total volume, and that will be 0.9048 plus 2.714. So adding those together and then correcting our answer to 3 significant figures as the question requested gives us 3.62 cubic centimetres. That's the volume of the pharmaceutical pill and the end of the question.